Today we're going to start 6.3 logarithms and logarithmic functions. All right, we're going to take 2 days to do this lesson. The first thing we're going to look at is we're going to try to solve this for x. So we're saying 2 to what power equals 8. So if you look back at the old form that we had when we were doing exponents, we would look at what had 2 as the base raised to what power equals 8. And we see that it's really 2 to the third power equals 8. So if 2 to the third equals 8 and x is the power, then x equals 3. Whereas if we looked at the next example, 2 to what power equals 6, we can't find it on our sheet. There is no value that is an integer that we can raise 2 to make 6, right? Because 2 to the first is 2, 2 squared is 4, 2 to the third is 8, and we've already jumped right over 6. So as it stands, we don't know how to solve this. So that's where our logarithms come in. So we have logs, and this is what a log looks like. It's the word log. There's a base b, and that's almost like a subscript to the log. Then of y, so then there's going to be a value after the word log, equals x. And this is only true if b to the x equals y. So a lot of times, I'm going to write it again because I'm going to show you what I'm going to do. Log base b of y equals x. The way I convert this is I start at the b, that's my base, I raise it to that power, and it then gets equal to the y. B to the x equals y. So I'm going to make this curve each time that I'm changing between logarithmic form, which was here, and exponential form, which is here. All right, so we're going to rewrite each of these equations in exponential form. So I'm going to start with the base, head to the 3, swing back to the 216. So that means 6 to the third power equals 216. And we know that that's true. All right, I'm going to do the same thing here. Start at the 1/5, head to the -1, and then swing back to the 5. So that's 1/5 raised to the -1 power equals 5. All right, so this is taking something in logarithmic form and rewriting it into exponential form. So you go ahead and try the next two. You're going to rewrite each of these into exponential form. Pause when you're ready, come back. All right, so there's your answers. 7 to the 0 equals 1, and 21 to the 1 equals 21. Now, both of these are actually things we should take notice of. Anytime a logarithmic equation equals 0, right, that means 0 is the exponent, it's always going to equal 1. Remember, anything raised to the 0 power is 1. And then if I have something equal to 1, right, that means the power was 1, it's going to equal what it originally was. So the base and the y value are going to match. So that's what this says here. A logarithm of 1, so a base of b, base of anything really, with a 1 here is going to equal 0 because b to the 0 will always equal 1. And then a logarithm of b with base b, if these match, it automatically equals 1 because b to the first power equals b. Now we're going to go the other way. We're going to rewrite the equation in logarithmic form. So I'm going to do the same thing. This is going to end up being my base. This is going to end up being the y value. And then this is what it's going to be equal to on the other side. So this means this is log base 20 of 0.05 equals -1. So I started at the 20 of the 0.05 equaled the -1. So I'm going to do the same thing here. It's going to be log base 16. So 16, then I go to the 8. So of 8 equals 3/4. All right. So you guys try the next ones. Pause, and when you're ready, come back and check your answers. All right, so for 3, we should have had log base 15 of 225 equals 2. And for number 4, we should have had log base 9 of 81 equals 2. You could always go back and check, make sure it makes sense, right? 15 squared equals 225. 9 squared equals 81. So now we have some evaluate. So we actually want to get a final numerical answer for these. So sometimes it helps if you were to write it as equals x. And it's helpful to turn this then into exponential form. So we're going to do 4 to the x equals 256. And now we're looking for 4 to what power gives us 256. And we can look back at that old sheet if we have it, or we could just keep raising 4 to different powers until we get it. And 4 to the 4th power is 256, which makes x 4. All right, for the next one, again, I'll put equals x, and it's going to be 8 to the x power equals 0.125. So what I would actually do for this is I would turn that 0.125 from a decimal into a fraction, because it might be easier to see where eighths came into play in this fraction. So you could either do 125 over 1,000, right? 3 places is the thousandth place. You could try to do 1.25 out of 100 or 12.5. That doesn't make sense, 12.5 out of 10, but 125 out of 1,000. All right, we get 1 over 8. So 8 to the x power equals 1 over 8. So now you have to say to yourself, what would turn 8 into 1/8? Basically, they moved the 8 to the denominator, which means 8 to the -1 power gives us 1/8. So x is -1. All right. You guys try these. Pause when you're ready. Come back and check. All right, for 5, 3 to the 3rd power is 27, so x is 3. 6 was a little trickier. It's 64 to the x power equals 8. So I know really the square root of 64 equals 8, and the square root of a number is really a 1/2 power. So that's why x is 1/2 there. All right, we're almost done with this lesson. A common logarithm is a logarithm with a base of 10. So they can show a base of 10, or they actually just usually write log. So if they do not give you a base here, you assume that it is 10. That's a lot like if you were to have a variable, if there was no number in front of it, we assume there's a 1 as the coefficient. Or if they didn't tell us an exponent, we assume that the exponent is 1. So if log doesn't tell us a base, we assume the base is 10. That is the common logarithm. Then there's a natural logarithm, and that base is e, right? We learned about e last week. So it can be written as log e. log base e, but that's not very common. It's actually going to be written as ln. And I know that's a little backwards. For natural log, it should be nl, but ln, log natural, is how they're going to denote that. We're going to be able to evaluate these. And we're not going to use a calculator. We're not going to do these in our head. We're going to use a calculator for these. There are buttons on your calculator that say log and ln. So I'm going to pull up some of them right now. So if you have the TI-36X Pro, you have one button that has both the ln and the log on it. So if you want the natural log, you hit it once. If you want log base 10, you hit it twice. If you have this type of calculator, the Casio FX300 ES Plus, there are two separate buttons, log and natural log. And then scrolling down, if you have the TI-34 Multi-View, which is the one I'm going to use to show you how to do it, there's the button, same way we were able to get to the E on the other problems, that log button, the PRB. You hit second and then that, and it'll give you some options. If you have the Casio FX300 MS, again, just like the other Casio, there's two separate buttons, log and natural log. And if you have a graphing calculator, there's two buttons on there, natural log and log, right above each other. So we are going to go, we're finding log of 21. So I'm going to go to my TI-34. Remember, log is here, so I'm going to have to hit second and then that button. And now you see I have log here and natural log here. So I want log, so I'm going to hit enter on log, 21, and I get my answer. So let's round it to three places. So I'm going to say 1.322. And that's the answer. That's all I have to put. For B, we want the natural log of 0.54. So let's clear this out. Again, I'm going to hit second, that button, and now I'm going to go over to natural log. So now I have natural log, and it was 0.54. So again, I'm going to go to three places. So I'm going to have negative 0.616. And that's all I have to do for evaluating these. All right, so you're going to try the last two using your own calculator, evaluate each. You can pause now, and when you're ready, come back and check your answers. All right, so if you got those, 1.079 for log 12, negative 0.288 for natural log of 0.75. And that is actually it for this part of the lesson.